All right, so let's look at more examples under multiple identities. Example 4, prove the following identities. Let us prove that this one is equal to that. Now I told you in trig, what we aim for is 1, to eliminate theta, 2, to find the angles given the range, 3, to prove identities. That's what you should expect on any subtopic of trig. We eliminated the theta on this. We got to see how we can get the angles given the range. Now we are in for the simple proofs. Okay, we have sine 3 theta equals to 3 sine theta minus 4 sine cubed theta. So what we're going to say here, we shall say solution. Shall say now from left hand side. I'm beginning from this side to show that that is true. Now say sine 3 theta. This is the same as sine of theta plus 2 theta. I think that's true. The sine of theta plus 2 theta gives you that. All right, good. Then here we're going to say this will be expand. Let's expand using the compound angle identities. This will now be sine theta plus sine 2 theta. Oh, sorry. Expanding using compound angle identities. Compound angle identities, shall say. You go and check in the playlist. We have the topic of compound angle identities. How can this be done? So sine theta cos 2 theta plus cos theta is sine 2 theta. Please, you go in the playlist and see how we expand using compound angle identities. The video is there. Now, this is A, this is B, if you are to go back there and refer. So this will now be equal to, shall now have sine theta. Now we have substitute for these ones with the tools using this hint. But now which hint are we going to use? Like, say for example, in the proof, in the very first point here, I have everything I have is in sine, meaning that even the identity I pick should be having the sign. So it means that here, for cos 2 theta, I put it in the bracket, where cos 2 theta is, I'll put this guy. So 1 minus 2 sine squared theta plus the cos of theta into, now sine 2 theta is same as this, a 2 cos theta, a sine of theta, as simple as that. Expanding, expanding. This will now be, this time is that will give you a sine theta, sine times that will give you, sorry, a minus 2 sine cubed theta plus, this times that will give you, all right, a 2 cos squared theta dot sine of theta. That's what we are having. Now, what next? What next? What next? We must make sure that we call off, we remove this guy. Why are we removing this guy? Is because the proof we have is only sine. We have sine everywhere. We don't have cos, so get away of removing cos. How? You all know that from cos squared theta is equal to 1 minus a sine squared theta. This from Pythagoras theorem. Okay. Now we are going to have a sine theta minus 2 sine cubed theta. Okay. Plus 2 into 1 minus a sine squared theta. Right. Bracket. It is a sine theta there. Let's simplify. You will get that a sine theta minus 2 sine cubed theta plus 2 minus, okay, plus 2, this is multiplying here, 2 sine theta minus the 2 sine cubed theta, like that. Collecting like terms, shall now have finally, collecting like terms, sine theta plus sine theta, you'll get 3 sine theta. So it will be 3 a sine of theta minus negative 2 sine cubed theta minus 2 sine cubed theta. You'll get 4 sine cubed theta. And you can now say quite easily, done. That's how we do that. Good. Let's now go to another proof. Let's now go to another proof, which is part B. Another proof, which is part B. So now this one will be solution. Solution. Now with this we shall say, that from left hand side, which is tan 2 theta is equal to, now I want to split tan into the ratios, which is sine 2 theta over cos 2 theta. That's what we're having, equals to, now I want to put or substitute, I want to substitute the angles, double angles, because the answer we have doesn't have a 2. This one has 2 theta, this one has only 1 theta, 1 theta. So I must call up this one using this. Sine 2 theta is equal to that. So therefore I will say 2 cos theta sine theta over. Now down here, cos 2 theta, which identity can I use? Which identity can I use? The data I can use here is, and take this, 1 minus, oh, even we can take the other one off. Okay. There is this one here. Cos 2 theta is equal to a cos squared theta minus a sine squared theta. Let me use this one, I think. Let me use that one. So cos squared theta. Please, any use gives you the answer. Any use gives you the answer, no problem. I've only opted for that. So next, now let's proceed. That's what we're having. Now here we have a tan. But here we have a 1. And how can we get a 1? This one is here. A minus. Then this one becoming a 1. Means that they are dividing all through by this guy. So dividing all through by cos squared. So we can say dividing all through by cos squared theta. Like that. So now that will be, okay, up we shall have 2 cos theta, a sine of theta, over a cos squared theta. Again, over, divide here, a cos squared theta, divide by itself, so that a 1 can come out as per the proof. Always when you're doing, it's good to refer to the proof. You look at the proof. You look at what you're going to get to help you figure out what they really want. So minus a sine squared theta over a cos squared theta. This will now give us, this is squared, it will cancel with part of that cos. Now a sine over cos will give us a 2 tan theta over cos divided by cos will give us a 1 minus sine squared over cos squared will give us a tan squared theta. Like that. So this will be tan 2 theta is equal to that. Hence, proved. All right, so let us proceed with more examples proving the identities. So we have part C is here. Prove that this is equal to that. Still, the magic remains from left hand side. So from left hand side, I start from this side. So that will be a cos 2 theta over a cos theta plus sine theta. Now it's good to look at where you're going. Where I'm going, it doesn't have anything like a fraction. I'm only having, it doesn't have anything like a fraction. I'm only having cos theta minus sine theta. So what must I do? Now I must bring in an identity for this, because in the final answer I don't have anything like cos 2. So I bring an identity for that, an identity, and that will be, I want to pick this identity here. Always use, in proofs, always use this identity. In the proofs, I advise you to always be using this identity here. Cos 2 theta is equal to this. So in the place of that, I will say a cos squared theta minus a sine squared theta over a cos theta plus a sine theta. Like that. We are in for this proof and see if it's going to come out. All right, now here, it means that now, do you see a difference of 2 squares here? Difference of 2 squares. Like what I'm meaning, when you have a squared minus b squared is equal to a plus b, a minus b. Now, here, this is the difference of 2 squares. So that for this one up, I have a right, write it like this. For this one up, I have a right, write it like this. I have a right, write it like this. This will be cos theta plus sine theta, then cos theta minus sine theta. That's only up. Then down I have a cos theta plus sine theta. Now you see that this guy down can cancel with this guy up. And what do you remain with? What do you remain with? You remain with the cos theta minus sine theta, which is this. Then I can say quite easily done, as simple as that. Okay. Let's now refer or go to part B. Tan 3 theta is equal to that. Now what are we going to do? Shall I say? From left hand side still, from left hand side. I'll now say this. The tan 3 theta is equal to a tan bracket theta plus 2 theta. You all know that trick. That's how I prove them, just like we did it for sine 3. Now this will be, now here just expand the normal way. This will be equal to expand. It will be tan theta plus tan 2 theta over 1 minus tan theta times tan 2 theta. Please, I'm expanding using compound angle identities. The video is there in the playlist. You can go back and look at it. So we have this one is equal to. All right, now, but you all know the identity, but I can say but tan 2 theta is equal to 2 tan theta. We proved this. This is also an identity, 2 tan theta over 1 minus tan squared theta, meaning that where I have tan 2 theta, you can put this guy. So this will give us a tan theta plus, where tan 2 theta is this. Where tan 2 theta is, we shall put this. So 2 tan theta over 1 minus a tan squared theta. This is over 1 to make it a fraction. Over, down, 1 minus a tan theta dot, all right, tan theta, okay, 2 tan theta. I'm substituting for this one, whereby I'll put this. 2 tan theta over 1 minus tan squared theta, as simple as that. Let's now continue. For this one up, the LCM will be, okay, allow me write it like this. For this one up, its LCM will be like this. Its LCM will be 1 minus tan squared theta. The LCM will be this. Now, this LCM divided by this will give you that times that. So it will be now tan theta into 1 minus tan squared theta. That is that. Okay. But then here we have, okay, plus. Now, this divided by that, it remains. So you'll just get 2 tan theta. Now, allow me understand. This one means divide. This one means divide, and you will allow me put here just division symbol. Then I look at the numerator, the denominator. Denominator still, the LCM is this. 1 minus tan squared theta. Now, LCM, remember this is also over 1. This is multiplying here. This is just a single stuff. So 1 over 1. So the LCM divided by 1, remember that the LCM times 1 shall carry this forward. 1 minus the tan squared theta minus, then here, this LCM divided by this is 1 times this whole thing. That would be, if you apply this times this, would give you a 2 tan theta, again tan theta, like that. So the next step we shall say, let's multiply. Oh, this will make the bracket. Multiply here, that will be now a tan theta minus tan cubed theta plus 2 tan theta over a 1 minus tan squared theta. Now, since this is a division sign, I will multiply. And once you multiply, you just know you'll get the reciprocal. Reciprocal, this goes up, will be 1 minus tan squared theta. This will come down, which will be 1 minus. Now this is tan squared theta. Okay, 1 minus tan squared theta minus 2. Minus 2. Tan times tan will also give you tan squared theta. Okay, good. Then with that, you realize that this one here and this will cancel out. Those ones there will cancel out. Then please allow me conclude that from here. Just allow me conclude from here. This one up over this one down. So this one is tan theta. Oh, This plus this tan theta plus 2 tan theta will give you 3 tan theta. Please maintain the equal signs. 3 tan theta minus tan cubed theta, like that, over a 1 minus, now tan squared, negative tan squared minus 2 tan squared will give you 3 tan squared theta. And you see that this proof is that one. So you can now say proved, hence proved. Thank you. Please don't forget to subscribe. It takes less than 1 second to do that. And it's the appreciation you can at least give to us. Thank you.